IPv4 addressing. In the IPv4 addressing architecture, IP addresses were originally divided into classes, which helped to determine the range and size of networks available within the overall address space. Here's a breakdown of the IP address classes, focusing primarily on those intended for public use. Class A range 1.0.0 to 127.255.255.255. Default subnet mask 255.0. Description: Class A addresses are used for very large networks, as they allow for a large number of hosts per network. The first octet represents the network part, and the remaining 3 octets are for the host part. The first octet range is 1 to 126. 127 is reserved for loopback addresses. Class B range 128.0.00 to 191.255.255. Default subnet mask 255.255.0.0. Description: Class B addresses are used for medium-sized networks. The first 2 octets represent the network part, while the last 2 octets are used for hosts. This provides a balance between the number of networks and the number of hosts. Class C range 192.0.0.0 to 223.255.255.255. Default subnet mask 255.255.55.0. Description: Class C addresses are commonly used for small networks, like small businesses or residential networks. The first 3 octets are used for the network, and the last octet is used for hosts. This allows for many small networks with fewer hosts. Class D multicast range 224.0.0 to 239.255.255.255. Description: Class D addresses are reserved for multicast groups. These addresses are used for one-to-many communication, with packets sent to a Class D address being distributed to all members of the multicast group. Class E reserved range 240.0.0 to 255.255.255.255. Description: Class E addresses are reserved for future use, experimental purposes, and research. They are not used in public networks. The concept of class-based IP addressing has largely been superseded by classless interdomain routing in modern networking. CIDR allows for more flexible subnetting and more efficient allocation of IP addresses than the fixed class system. Nonetheless, understanding IP classes is still useful for grasping fundamental networking concepts. Private IP addresses are reserved IP addresses that are not routed on the Internet. These addresses are used within private networks, such as home networks, office networks, and enterprise environments. The allocation of private IP addresses is defined in standards like RFC 1918 to prevent IP conflicts and address exhaustion. Here's a breakdown of the private IP address ranges by classes. Class A range 10.0.0 to 10.255.25.255. Default subnet mask 255.0.0. Description: The 10.0.8 network is the largest block of private IP space available under Class A. It allows for a massive number of hosts, making it suitable for very large organizations or networks requiring a lot of subnets. Class B range 172.6.0.0 to 172.31.255.25. Default subnet mask 255.240.0. Description: The 172.16.0.0/12 range encompasses 16 contiguous Class B networks, providing a good balance between the number of network addresses and the number of hosts that can be accommodated in each subnet. This range is often used in medium to large-sized networks. Class C range 192.168.0.0 to 192.255.255. Default subnet mask 255.0.0. Description: The 192.168.016 range covers 256 Class C networks. It's the most commonly used range for small business and home networks because it allows for up to 256 networks with 256 hosts each, sufficient for these smaller environments. Additional private addressing 100.64.0 to 100.107.255.255, 100.64.0/10. This range is designated for use in carrier-grade NAT environments. It is not meant for use in private networks, but rather in situations where an internet service provider must manage IP address overlaps when routing traffic from multiple private networks. The use of these private IP ranges allows organizations to create internal networks without depleting the public IP address space. Devices within the same private network can communicate with each other using these IPs, but they require address translation, typically through NAT, network address translation, to communicate over the Internet, where public IPs are necessary.